All right, here we go. You ready? First things first, you guys need this definition, and it is, let's start with hypertonic. Oop. Yeah, it's frozen. Sorry, hold on. All right, there you go. Hypertonic is the first definition that I think you guys should have. So I'll bring it down here. And it says, if you have a hypertonic solution, that means there's more solute inside. I'm sorry, this is hypotonic. Hypotonic, there's more solute dissolved inside of the cell. All right? What's a solute? Do you remember that? A solute is something that's dissolved. So in this case, it's salt. Salt is dissolved in the water. So if we have a hypotonic solution, which is exactly what we've got going on here, count the orange dots. How many are inside the cell? 1, 2, 3, 4, 5, 6, 7. How many are outside? 2. All right? So where is there more solute concentration? Inside the cell, right. So what's going to happen is water is going to go where there's less water and more solute. So that means what? Where will water go? Water will go inside of this cell. Here's a real simple way to remember this. Water will always go where there are more dots. Okay? Water will always go where there are more dots. So in this case, water will go inside. Now, predict what's going to happen to this cell. Yeah, good. It's going to expand. It's going to get bigger. All right? Because water is going to go in. This is exactly what we're going to do in lab. All right? So a hypotonic solution means that there's more dissolved stuff, more salt, more sugar, whatever, inside of the cell. So water will rush in there to try and dilute that. Okay? Got it? That's hypotonic. Next one, hypertonic. Here's my definition, real simple. There's more solute dissolved outside the cell. All right? So how do we make that happen? Well, move my dots. All right? Does that look hypertonic? Are there more dissolved things outside the cell? Yes. So what's going to happen? Can anybody tell me? Yeah, water will go out. The water goes where there's more dots, right? So this solution here is what we call hypertonic to the cell. Water will go out. What's going to happen to the cell then? It's going to shrink. So what is that? Can you think of a situation in real life where this would happen to you? Where your cells would shrink and shrivel up and lose water? If you're dying of thirst floating around in the ocean, do you think it's a good idea to just say, well, you know what? Salt water is better than no water? No. Yeah. If you drink salt water, that will actually take water out of your cells. So it's better to not drink anything at all than to try and drink the salt water, because if you drink the salt water, it's just like this. It's just like this example here. This would be your body cell, and this would be the solution of salt water floating around inside your stomach, and all your cells would lose water to try and dilute all that salt water, and your cells would actually shrivel up, so you'd get dehydrated faster. I think the ratio is 5. Every glass of salt water strips 5 glasses of regular water out of your body. So it's going to just speed the process up. All right? So that makes a hypertonic environment right there. All right? So water will go out. That one okay? All right, last one, the easiest one of them all is, not that, isotonic. And I don't know, I have to count how many I have here and see if I can make it happen. You guys tell me when it's even. We've got 1, 2, 3, 4, 5, 1, 2, 3, 4, so I need to get rid of one of these. We'll just do it that way. Bam. All right. Are we even now? So what kind of solution do we have? We have an isotonic. That means equal amounts of solute inside and outside. So what do you think is going to happen? Yeah, water will... Yep. It'll just kind of flow equally in and out. What's that going to do to the cell? It's going to stay the same. All right? There'll be no increase in size, no decrease in size, no anything. All right? There's a couple terms that go along with this that we're going to talk about tomorrow, but for right now we're just going to leave it at this. The basics of, what's this process called again? Water, the diffusion of water. Would you like a hint? Osmosis, good. All right. Okay, so there you go. That is the basics of hypertonic, isotonic, and hypotonic solutions.